With a single dictionary, there are a lot of things you can do. For example, imagine you want to count the most common words in a certain block of text. We did an example of this a long time ago with counting a single word, but here we want to count how many instances there are of every single word in that block of text. How would you do that? Well, the first thing you'd probably do is go through that text and remove all the punctuation marks. After all, we don't want to differentiate count and apostrophes from the word count with a period. After that, we would probably also go through and convert the entire string to lowercase. That's because we don't want to count a capitalized it as a different word than a lowercase it. But after we do that, what do? Well, the next thing we might do is split the text by spaces. We want a list of individual words, not just one long string. And so that would give us something like this. It's a list of individual words as specified by the apostrophes and the commas. Note that originally we removed the apostrophes and commas, but that's because the apostrophes and commas were part of our text. Here they're specifying individual words like a list of individual words. Now we're ready to start actually counting how many times each word appears. We go through the words one by one, and if we encounter a word we haven't seen before, we add it to our dictionary with an initial count of 1. We continue and add each word as we encounter them for the first time. In this series of words, it's going to be a while before we actually encounter a repeat word. In fact, the first repeat word we'll encounter is this. When we encounter that first repeat word, instead of creating a new key in our dictionary, we're instead going to grab the current key and change its value to whatever it was previously, plus 1. So the keys in our dictionary are those individual words, and the values are how many instances of each word have been found so far. That way, for each word we encounter, we can very quickly look up its current value. We don't have to iterate through a bunch of numbers in a list to find the one that corresponds to that next word. We just use the word itself as the key to look up its current value. Or alternatively, imagine you were creating a seating chart for a wedding. How would you do this? You could have a list of all the seats, or you could have a list of tables, each of which has a list of seats. But that would mean you would need to know the table and seat number to look up who is sitting there. And in all likelihood, that's backwards. You're not generally asking yourself, who's at table 5, seat 3? You're generally looking up, where is David sitting? So you could do this with a dictionary instead. Here, the keys for our dictionary are the individual names, and the values are the table numbers. Here we're assuming we don't have assigned seats at each table. So if I want to look up which table Sophia is sitting at, I can immediately just look it up and find that the answer is 2. It's similar to having a variable called Sophia with a value 2, but this way we can pass around the entire seating chart with one variable name. And we can add more to it or remove people from it without creating new variables or removing existing variables. So we could actually let our user put in names and numbers, as opposed to requiring variables be created for each person right there in our code. We could also actually make these assignments both tables and numbers. For example, instead of just table numbers, each one could be a tuple, including a table number and a seat number. That gets into our more complex application of dictionaries, merging dictionaries with lists, tuples, arrays, or even other dictionaries.